Hi there, welcome back to this channel. In this video, we are going to be discussing the concept of projectiles and equations of motion. Now, in this video, we are not going to be treating questions yet. We are going to treat questions on projectiles in further video. But what we basically want to achieve in this video is to make you be able to understand the concept of projectiles, the equations, how you can by yourself derive the equations on your own without having to cram. So the concept of this video is to avoid cramming. For you to be able to come up with these equations on your own without having to cram them. So that is the idea behind this video. Now, starting with the equations of motion. Now we're going to be, before we get to projectile motion, we're going to be starting with our translational motion. Now, translational motion that we have seen before or worked with, and such as the one we plot on a velocity time graph, is a motion in one dimension. It is only a motion on the x-plane, is that okay, on the x-axis, or maybe only on the y-axis sometimes. So if we are observing that motion alone, we deal with only one plane. So we will talk about quantities like speed. We'll talk about quantities like velocity. We'll also talk about quantities like acceleration. All right. Now, but the first thing I want to talk about, that I want us to keep at the back of our mind, is that we are still observing a one-dimensional motion. And that is what separates it from a projectile motion. Projectiles move in two dimensions, rather. So this motion is two-dimensional, the projectile motion. Why? Because the body is going to both observe a translational motion and what? An upward motion. It's going to observe translation in both axes. So it's going to observe an upward movement and a horizontal movement. Is that okay? So a vertical and horizontal movement. So that is why we say it is two-dimensional. Now, beginning with the first equation, what is speed? Speed is defined as what? The distance moved by a body per time. So that is how much distance a body covers per time. That is the speed of a body. But we said velocity, which is almost the same, but it's different in the sense that velocity is a vector quantity. And whenever we talk about vector quantity, people don't usually understand what the concept of vector means. Vector simply means that when we talk about velocity, it means that we have direction in mind. They are essentially the same thing, talking about the same thing, but when we use the word velocity, it means that we have vector in mind. We understand that we have direction rather in mind. So for example, if I said I ate rice, for example, I need not tell you that I cooked it. So that I ate it means I cooked it. Is that okay? So that when we use velocity means we have direction in mind. It means that we understand that there is direction involved. Is that okay? So that is why it's a vector quantity, while speed is a scalar quantity. So velocity is basically displacement, and that is what, not distance now. That is now a particular directional distance. Yes, it's still distance, but it's directional, and that is what separates velocity from distance. So we said it is S over T. That is velocity. And then acceleration is what? Acceleration is change in velocity. A change in velocity over a change in time, our time. So if we represent final velocity with v and initial velocity with u. Then our equation becomes v minus u over t. So this becomes our equation 1, this becomes our equation 2. So it means that from here, we can derive a new equation. If A is v minus u over t, it means that we can derive a new identity for a new relation for v. And v therefore becomes what? We will cross multiply and have v minus u equal to at, so that v will be equal to this goes there, and we have u first plus at. This becomes equation 3. This is equation 3. Now, there is also one equation that says that average velocity, because from here, we can talk about average, from here rather, we can talk about average velocity. So average velocity is equal to distance or displacement over time. And what is average velocity? Average velocity simply means we have an initial velocity and a new velocity. Initial velocity could be 0, could be any number, could be any speed at any velocity at which the body was moved initially. So this would become v plus u. I mean, where you have over 2. I mean, where you have things like if I said take the average of things, of 2 things, that would be the addition of those 2 things over 2. So if we are taking the average of the final velocity and the initial velocity, it becomes that plus the final plus the initial over 2. All right. So this average velocity is equal to distance over time, or displacement over time. So that displacement will therefore be equal to what? So 2s will be equal to t into bracket v plus u. So divide both sides by 2, and you have what? S to be equal to v plus u over 2. Now I want to put the t outside there. So this is another equation, and this will be our equation 4. This will be our equation 4. So remember where we are getting those equations from. All right? This will be our equation 4 now. From equation 4, I could decide to bring in a number of things. So for example, since v is this in equation 2, in equation 3, v is u plus 80. V is u plus 80 in equation 2. And now stick with me. If you already know how to derive this, stick with me, because I promise you we are still going to further derivations that you probably have not even seen before, or because we're going to be playing around maths here. Is that okay? And that is the purpose of this video. Know how to derive a number of equations. Is that okay? So stick with me. And if you already know this, you can even skip the video. Is that okay? And if you have not already, please do also subscribe to the channel. All right. So we have v is equal to u plus 80, and that is equation 3. So we are going to solve that into equation 3. Equation 4. Solve it into equation 4. And equation 4 says this. So we have s to be equal to, where we find v, we put u plus 80, then plus u over 2 all t. So s becomes 2u plus 80 all over 2 all t. So this becomes 2 into bracket. Let me separate this out. Let me distribute the t. If I distribute the t, 2u times t equals 2ut plus 80 squared all over 2. If I also distribute these 2, I'm going to have s is equal to 2u individually over t plus 80 squared individually over 2. Isn't it? Because the LCM of this is 2 and 2, so we have this back. Is that okay? So this takes care of this, and s is equal to what? ut plus 1 over 280 squared. This is equation 5. So that is how that equation came about. I mean, if you have seen it before, so that is how it came about. Now, there are other things we could do here. Now, from equation 4, let's start from 3 first. From equation 3, you know that 3 says v equal to u plus 80, which is equation 3. It means that t, or 80, will be equal to v minus u, isn't it? And t will be equal to v minus u over what? A. This is another equation. Let's just hold this. Or maybe let's make it equation 6, because it's equation of time. All right? And from 4, and I bet this was not the way it was derived for you, the way I want to derive this. From 4, we could say that by dividing both sides, you know this is 4 here, s equal to v plus u over 2 all t. I could Divide both sides by this guy. If I divide both sides by this guy, over v plus u over 2 and v plus u over 2. This takes care of this. So that our t will become s over v plus u over 2. So this guy comes up, t equal to 2s over v plus u. In case you don't understand what I did, let me just quickly show you. If you are dividing by a fraction, all you have to do is take the denominator of the fraction up to multiply the first numerator and over the actual numerator of that initial fraction. But if you are dividing a fraction by a number, the opposite will be the case, like this. So for example, if I have 2 here, like say 2 divided by half, this should become 2 over half. So right? So this should come up to give me 4. 4 over 1, which is 4, isn't it? But if I were to be dividing half by 2, this will be 1 over 2 over divided by this 2, isn't it? So what should happen is that this should come up, this 2 should merge, should be 1 over 2 times 2, that will be 1 over 4. You saw the way I did it? If I were to divide 3 by 1 over 4, divide 3 by 1 over 4, this should become 3 over 1 over 4. So this becomes 3 times 4 over 1, which is 12. Do you understand? But if I were to divide 1 over 4 by 3, because to divide fraction by whole number, just bring the denominator of the fraction up. But to divide whole number by fraction and divide a fraction by a whole number, what you do is this will merge, just become 1 over 4 times 3. That's 1 over 4, 12. That should be a trick for you. Is that okay? So for some of you, you already understand that trick anyways. So we're going to just proceed. So that was what I used here. I'm dividing by a fraction here. So 2 goes up and I have 2s over v plus 2. So this is equation 7, for example. So if equation 6 says t is this, and equation 7 says t is also this, definitely v minus u over a is also 2s over v plus u. Very simple. You know, this is our equation 6. It says t is v minus u over a, and equation 7 is saying that t is also 2s over v plus u. Is it showing that for you? Okay. So since t is this and t is this, definitely this must be equal to this. Is that okay? Then we can cross multiply and have 2as will be equal to v minus u times v plus u. If you recall vividly in maths, this is what you have in difference of two squares. Remember, if I have a squared minus b squared, what will it become? It will become a plus b and a minus b, which is exactly this, right? So it means that this is going to be v squared minus what? U squared. All right. So what do we have? 2as will be equal to v squared minus u squared. And if I make v squared, sorry, formula, become v squared is equal to u squared. That goes there, u squared plus 2as. And this is equation 8. Another way to derive this, another way of deriving this is to substitute the value of, you can substitute the value of this guy into this equation, which is s, into this equation. If you substitute into this equation, let's try that out and see what we have. No, okay, no, since we want s to appear, if you want s to appear, you could substitute, another way of deriving that is to substitute u here, v equal to u plus at. If you substitute that into this place for u, you should be able to get this same equation. You should be able to get this same equation. All right. So that is how, you know, I've derived mine. Now you can try on different things. For example, we could decide to try on that by substituting from there. We know that u will be equal to Or let's make t subject since it's still t. We could decide to substitute t here. You know t is 2s of v minus u over a. Let's use this one. V minus u over a. And s is equal to ut. This is from equation 5. S equal to ut plus 1 over 2 at squared. Okay? I could say since t is this, since t is v minus u over a, then it means that x will be equal to u into bracket v minus u over a. Oh, this is going to be long. Let's still try. So we have 1 over 2 here. 1 over 2 times, so that will be a into bracket v minus u over a all squared. Alright, with this all squared. Alright, so what are we going to have? I'm going to have to bring it down there. Well, let's manage this question. We have s to be equal to, this opens the bracket to give us uv minus u squared over a plus, I have here a will open the bracket to give me, now because this will be a squared, this will be v minus u all squared. Is that okay? A squared would take care of, you know, this is supposed to be over a squared. So one of the a's will take care of this a. So this becomes over a all over 2. Now remember that this is a fraction on top being divided by a whole number. So what do we have? We end up with over 2a. I hope that is clear. So that when I can rewrite this to what? uv minus u squared over a plus v minus u all squared over 2a. Why? Because I'm dividing by a whole number by the trick that I showed you the other time. Let's bring that back here. I hope you are writing all the equations down. Make sure you are dubbing all the equations down. So we could have that. So we'll take the LCM of a and 2a. The LCM is going to be 2a, right? So s will be equal to 2a. Then we have a in 2a. It's going to be 2 times that will give us 2uv minus 2uv squared. 2v squared rather, 2u squared. 2u squared plus 2a in 2a will give us the same thing, v minus u all squared. Now, let's open this bracket up. We have s will be equal to 2uv minus 2u squared plus this squared. If you decide to open this bracket, you have v minus u. Is that okay? So just square this, and 2uv minus 2uv minus plus 2uv rather. Let's try v squared equal to minus this times this minus uv plus u squared. Yes. So you are going to have v squared minus 2uv plus u squared. Is that okay? So that is that. Now all over 2a. So this becomes s. Now 2uv and 2uv can take care of each other. Is that okay? The v squared comes first. V squared minus 2u squared plus u squared. Okay, they are the same again. They can take care of each other, right? Like, I mean, 2u squared minus 2u squared plus 2u squared plus u squared. That is minus 2a, for example, minus 2a plus a. That'll give me minus a. So here to minus 2u squared plus u squared will give me what? Minus u squared. So I have s will be equal to v squared minus u squared over 2a. 2a. So I can cross multiply. Remember, we got it the same thing back now. So we have 2as equals v squared minus u squared. So we have v squared will be equal to, this guy comes in again, u squared plus 2as. You see, it's quite rigorous, but it's not even as rigorous as what we still do, but like you could easily come from here and derive your equation. So I'm just showing you the different ways by which you can derive the equation. So And try it on yourself, because you should master these things in order to prove that you already understand the equations. You're not just picking them off, or cramming them, and you could forget. So that is the use of mastering them. All right. So these are the fundamental equations of motion. So far, the fundamental equation that we derive are v equal to u plus at, and s equal to u plus v over 2 all t, and then v squared is equal to u squared plus 2as, and s equal to ut plus 1 over 2 at squared. So these are the four fundamental equations that we derived. Now let's bring this on to projectile motion. I'm going to clean this. Now, how does this now relate with projectile motion? First, what is a projectile? A projectile is a body that is made to move in a two-dimensional space. A body that moves in a two-dimensional space, which are the vertical and the horizontal planes at the same time. So a body projected in space to move in two dimensions, in two planes, to move. So each point along its path represents two coordinates. Is that okay? Represent two coordinates. So that is why we say it is a two-dimensional motion. Why? Because we represent it. So a projectile is just a body that I launch into space. So when I launch into space from a particular height or a particular level, it's going to come back down to that level, provided that I throw it at the same plane with the place the body lands. So if I launch it from the ground, it goes up and goes back to the ground. Is that okay? So its path is exactly like this. Do you understand? So it starts from a horizontal surface and gets back to a horizontal surface. So this body along each path at each point is moving in a vertical direction and also moving in a horizontal direction. So that if I pick this point here, this body has moved to this point here in the horizontal axis and has moved to this point in the vertical axis. So that's how we call it two-dimensional. It is moving what? In two dimensions. In two dimensions. So, of course, this is its part, but it has, so it means that it can be resolved into two planes, it can be resolved into two planes. So we can resolve it into the x plane, we can resolve it to the x plane, we can resolve it to the y plane. Now, what is the use of this? Now, first say that the curve is parabolic. So, parabolic curve. So that is parabolic means that what kind of equation gives us a parabolic curve? A quadratic. So that shows you that at the end of the day, we should arrive at a quadratic equation when we work on the path or the trajectory. The path taken by a projectile is called a trajectory. So what I launch is actually the projectile, and the path that it takes, the path taken by a projectile, it's called its trajectory. So by the time we evaluate the equation for the trajectory of this motion, it should give us a quadratic equation. Why? It should give us a quadratic expression because the path even traced, the path taken by that projectile is seen as a downward facing parabola. And because it's even downward facing, it shows you that the constant is going to have a negative value, right? Okay, so that, if you understand the concept of quadratic equation and the curves, You're going to understand what I just talked about. So let's analyze this guy. So when we'll be talking about the equations that will define this, so we said that one thing about this is that the velocity cannot be viewed in only the horizontal plane, but actually also on the what? The vertical plane. So it has a vertical velocity, which we have as we call the Vy, and we have a Vx or V sub y and V sub x. So meaning that it has a velocity along the y plane and a velocity along the x plane. Is that okay? So the velocity along the y plane is going to be called the Vy, and the velocity along the x plane is going to be called the Vx. So this can naturally alter all those equations, so that at the horizontal plane, at the vertical plane, or on the vertical plane rather, we're going to have our V there to be Vy to be equal to what? Uy plus At. So this is going to be our first equation. S is going to be the vertical displacement. So we have Sy because what? Uy plus Vy over 2r times t. V squared is also going to what? Vy squared plus is equal to u sub y squared plus 2a sub y s. So this is going to be the equation for the vertical displacement. Sy also is going to give us what? Uy t, u sub y, s sub y is equal to u sub y plus 1 over 2a sub y t squared. All right, because the time is not changing, so that's why time is not counting in subscript. The time is not changing throughout. All right, so then the horizontal equivalence of this will be V sub x equal to u sub x plus a sub x t. This should be a sub y. Is that okay? T. Then s sub x will be equal to the same thing, just alter these values, change these guys to x. This should be, so provided that there are constant velocities, constant acceleration, is that okay? This will be the alterations that will happen to our equation. But actually, if we are to analyze this equation, we know that first, we already know that this u, which is our velocity, understand that u is u and v is 0, because v is our final velocity. And also understand that since the body is moving in 2 dimensions, upward and also in this direction. So it's going to take a path up first and then come down back. Is that okay? So when it goes up, by the time it's going up, it's starting with a velocity. That velocity will constantly reduce until it gets to 0 here. So velocity here is 0. Velocity here is maximum. Velocity here is maximum until it touches the ground again, where it becomes 0. Velocity here is maximum, and is maximum again just before it touches the ground. Velocity will reduce until it gets to 0. So at maximum height, if I throw this body up, there's a point where it got to and it stopped before it began to drop again. At that point, V is 0, and the point where it started, it was maximum, and the point where it began to drop, it began to increase downward until just before it touched my hand again. Just before it touched my hand, it hit its maximum again before resting and becoming 0 at my hand at the time it touched my hand again. So do you understand what that means? It means that u will be 0 here, u here on this plane will be uy, and u on this plane what? U sub x. So that at the vertical component, so vertical component velocity, so it means that we have 2 vectors here. The first vector is the uy vector, and so these are resultant vector, which will be the u, and this is u sub x vector. All right, so these 2 vectors, in resolution of vectors, you know what we have. So that our u vector will therefore be equal to what? We can take it in 2 ways. So if this is this can also be the u sub y vectors. So this, if this is the resultant, it means that using Pythagoras theorem, we have that u squared will be equal to what? U sub y squared plus what? U sub x squared. So that u will be equal to the square root of u sub y squared plus u sub x squared. All right. So that is the equation for the resultant velocity. This resultant velocity here. And recall that we can also take the angle between them. So since the path we are looking for is this, which is standing as the hypotenuse in this triangle. So what do we have? We're going to be taking the opposite. If this is our angle here, the angle between them. If this is our opposite and this is our adjacent, then we have that tan theta equals what? Mu u sub y over u sub x. And this is going to be the equation for the angle between these 2 points. All right, for the u velocity, the u, our resultant u. Right. So now, how do we evaluate? Now, there are some things that we are supposed to, that are very important about this projectile. We have what is called the time of flight, or total time of flight, as you will see in some of the textbooks. Time of flight is the entire time that it took for the body to move from the point of displacement of its projection to back to the same plane. So total time of flight is the total time it took to fly until it came back to rest. That is time of flight. And there's something called, there's what we also analyze, which is the maximum height that it attained. So this point here, it's its maximum height. And remember, I said that at maximum height, before it began to drop again, the u will be 0. So since u is 0, we have maximum height, where s will be maximum and u what? 0. And there's also something called the horizontal range. The horizontal range simply refers to, whilst the maximum height refers to the height, the maximum vertical distance that it reaches, the range refers to the maximum horizontal distance that projectile covers. The range refers to what? The maximum horizontal distance it covers, while the maximum height refers to the maximum vertical distance that it covers. And these are the guys we are going to be working on, individually. So first, let's talk about, now, what is the u of the x component? So v on x component is going to be ux. Our ux rather is going to be, what? Since on x component, how do we get this ux, which is here? You know that we have this place to be ux, and we have this place to be our u, and we have this place to be ui, and this is theta. So what does this tell us? Our ux, to find ux, is going to be u cos theta. Now, the trick here is this. When you are closing an angle, when you are resolving this u vector to the horizontal component, you are closing this angle. So if you are closing an angle, you use cos. And if you are opening an angle, closing, cos, opening, sine. Is that okay? So it means that if we are resolving this to the vertical component, we'll be opening up this angle. So ui therefore what? U sine theta. And it's very simple. It's not hard at all. For example, if we are looking for ux, and we have our u. So it means that what trig function relates u and ux? U is standing as the hypotenuse, and ux is standing as the adjacent. So what trig function relates there? That is cosine of theta. Cosine of theta says that adjacent over hypotenuse. Adjacent over hypotenuse. So cos theta is equal to adjacent, it is ux over what? U. And this becomes what? Ux because what? U times cos theta. So that was how I came about this. But the trick, if you don't know how to begin to go through this, is just say that when you close an angle, it is cos. When you open an angle, it is sine. So here, so u on x component of what? U cos theta. And u on y component of what? U sine theta. So it means that our velocity on this component, on this axis, is going to be u sine theta. So this is u sine theta from what we have there. And u here is going to be u cos theta. Don't cram. It is understandable. U on y component, u sine theta. U on x component is what? U cos theta. Then from here, we can begin to derive our equations. So first, let's talk about the velocity on y component. Now, remember, if we have a velocity on y component, and we have an acceleration on y component, the acceleration on y component is going to be negative g. Why? Because it's going to be moving against gravity. Remember, when something is going up, it's going to move by negative g, and when something is coming down, it's going to move by g. It's going to move by acceleration due to gravity. All right. So that's why we have negative g. And then on the horizontal component, a is going to be 0. Simple. It's simple. If I projected the body only on the translational motion on the horizontal surface alone, the body is going to constantly move. Inertia, remember? U is going to be 0. U is going to be the same throughout. So it's going to have a uniform velocity. And when you have uniform velocity, acceleration is what? 0, because acceleration is what? Change in velocity over time. So, and velocity will not change throughout if it was just on the y component. So when we are considering the y component of the x component, this plane, the x component, our a is going to be 0 for our maximum range. When we discuss maximum range, our a will be what? 0. All right. So what does this tell us? It means that on the y component, Vy is going to be what? U. Remember that U is now U cos theta, Ux. I mean, Vy and Uy. Uy is now U sine theta. So we have U sine theta. On the y component, A will be negative g. So that will be minus gt. Do we understand? Minus gt. This is our equation. Now, also so this is on the y component. So for x component for this equation will become what? X component will be what? V sub x will be equal to what? Or u, let's use u sub x now. U sub x, not v sub x. U sub x, because now u sub y there. U sub y also because at maximum, v will be 0. At maximum height, v will be 0. So why we are just going to use the initial velocity that it takes to any height. So u sub y here and u sub x here. Also here, the reason why we are not using v is because by the time it gets here, the maximum the velocity will be 0. Is that okay? At the end of the day, velocity when it gets to stop again, when the body gets to this place, it stops. V is also 0, so we are using u for that reason. It's going to be u cos theta here. U cos theta. Now, remember I said that on this plane, this guy will be 0. Acceleration will be 0 on the x component. So that's why we're having ux to be just what? U cos theta. So let this be equation. This be our first equation. Equation 1 for projectile now, and this will be equation 2. Also on y component again, let's take the second equation. Remember this second equation. Let's take this equation first. Let's take this equation. So for this equation, on our y component, s sub y will be equal to what? Uy. What is uy? Uy is what? U sine theta. Uy is u sine theta. So that will be u sine theta times t. plus on y component, we have 1 over 2 minus gt squared times minus g t squared. So what does this become? S sub y will be equal to u sine theta. So times t, that gives us ut. Is that okay? And it's not sine theta t, it is ut, because this is a function on its own. So this times this will give us t at the back, at the back here. So ut sine theta is equal, plus times minus gives us minus gt squared over 2. So this is another equation. Now, also, on the x component, using this same guy, this same equation, for the x component, we will have that. So this is the equation for the vertical velocity, vertical component of the velocity. This will be the equation for the horizontal vertical displacement. This will now be the equation for the vertical displacement. So for vertical displacement, horizontal displacement, vertical displacement for y-axis, horizontal displacement for x-axis, that's why it's s sub x will be equal to u. Now, that I said it onto what? Ux here, t plus 1 over, now a will be 0, so everything will be 0. So s sub x will be equal to what? Ux sub t. U sub x times t. So what is u sub x? That is u cos theta. U cos theta. So u cos theta, the velocity we started with, cos theta, or the velocity we are given, cos theta, times t. Is that okay? So this becomes s sub x will be equal to what? Ut cos theta. And we can go on and on and on like that. This becomes the equation of our vertical displacement, horizontal displacement. These are horizontal displacement. Now, the next thing we can do is, let's find the time of flight. What is the equation for the time of flight? So, since we know that the body is essentially moving in, we can use any of the equation we have used before. Since we know that the body is moving in both vertical and horizontal displacement, horizontal axis, let's try to use this equation to find our displacement, our time of flight. So time of flight, recall that for time of flight, recall that uy from equation 1, uy is equal to u sine theta minus gt. So uy at maximum height, first, let's take the time, let's calculate the time it will take to reach the maximum height. The time it will take to reach the maximum height, at that point, u will be 0. So 0 will be equal to u sine theta minus gt. So that gt will be equal to u sine theta. So that t will be equal to what? U sine theta over g. This is the time it took to get to its maximum height. This is not the total time of flight, the entire time, the time of flight. This is just the time it took to get to the maximum height. So what would therefore be the maximum height? We can just say, since the time it took to get to the maximum height will be equal to the time it will take to get back to the point of displacement, then it means that it will be what happened here plus what happened here. It will be just two of the, because the time it will take to get here is the time it will take to get here. That will be t will be equal to t. Is that okay? So t plus t will be equal to the entire distance. So which will be equal to the time of flight. So the time of flight will just be 2 times of this u sine theta over g. And that is our next equation. So we said this was equation 2, equation 3, equation 4. So this is our equation 5. So these are equation for time of flight. There are other ways to derive this. So for example, we can derive it by using, let's use one of these equations here. This equation has t. So let's use this equation. All right. Since we know that S, this is one we can, because this is displacement. So this is the equation we use to derive maximum height. Let's try and use the other equation rather instead. V squared. So if it's on y, so it could be on x component. If it's on x component, what we'll have is y will be equal to v sub x will be equal to u sub x all squared minus, plus 2ax sub x s sub x. Is that okay? Now, okay, we can't use x component. Why? Because a will be 0. So let's use y component. So we have y sub y. So u sub y, we can use u sub y will be equal to what? U squared. Okay, that would be v sub y will be equal to u sub y, v squared. I'm coming from v squared equal to u squared plus 2x. Is that okay? I'm just trying to work math here. You understand? So bear with me. So v squared will be equal to, now a will be minus g because we are considering horizontal component. U will be equal to a will be minus g, so that will be minus 2gs. Do we get this? Okay, we can't still use this to get our total time of flight. We cannot still use it to get our total time of 0 at maximum vertical as maximum height. So this is the equation we're going to use to derive maximum height. So AS here will become H, maximum height. So at that point, this guy will be 0. So 0 will be equal to UY. Remember that UY is U sine theta. UY is U sine theta. Okay, I've put it here. So since UY is U sine theta, I could just write U squared, U sine theta all squared, because UY is U sine theta, so all squared, minus 2G H max. That's our maximum height. So we can bring this guy to this side so that we have 2GH max. So that we have 2G so that we can have 2G H max is equal to U squared sine squared theta. Alright, so we can therefore find and make H max object of formula so that it becomes U squared sine squared theta over 2G. And that's the formula for finding maximum height. And that is equation 6. Alright, so how about the formula for finding the maximum range? We've talked about the fact that we would also need to evaluate the range of the equation. Now, the equation that we're going to be using to evaluate the maximum range, the equation that we're going to be using to evaluate the maximum range, since maximum range is on x-axis, it means we'll be using this equation. So range will be equal to u cos sx, s sub x is equal to u cos theta t. Alright, so this is the equation we're going to be using. So all we need to do is just substitute. So you remember that time of flight is the total time it took from the beginning of the path of the movement. So from beginning here to the end. So that's total time of flight. So our maximum range from here to here. So this t will be the time taken to move from here to here. Is that okay? So which is going to be maximum total time of flight. So recall that t is equal to 2u sine theta over g. So what do we have? We have that s sub x will be equal to u cos theta times 2u sine theta over g. Okay, so from here, what do we have? We have that s of x will be equal to u times this becomes u squared times 2 cos theta sine theta all over g. So recall that this part, that 2 cos theta sine theta is equal to sine 2 theta. When you evaluate it, that is sine of theta plus theta. So this is what you are going to get when you evaluate sine of theta plus theta. All right. So we have s of x will be equal to u squared sine 2 theta over g. And this is the answer, the equation. So this will be equation 7. This will be the equation for the maximum range. Now, another way to find the maximum range, there's another way we can find the maximum range, and that is by using the equation. Well, okay, we're going to find the maximum range, but before we do that, let's go on to the last part of this, which is trajectory. The equation that we can use that represent this trajectory, this downward facing parabola. So, I talked about the fact that that equation is going to be quadratic because it's giving us a downward facing parabola. So in fact, we are going to be using this equation, s sub y, because we're going to have s sub y equal to ut sine theta minus gt squared over 2. So we're going to be using this equation because it looks quadratic, in fact. So let's see what we are going to come up with when we have that. So from here, we know that s sub x, we know from here that t will be equal to s sub x over u cos theta. So we have this, making t subject of formula here. So, and we know that s sub y from that equation we had was ut. Now this u was the u on y-axis, right? So that'll be u sine theta. That'll be ut sine theta because u sine theta minus gt squared over 2. All right. So here we can now substitute, since t is this, we can substitute that into this place. And the reason why we will be able to substitute that is because time here is with respect to the horizontal range throughout the entire path of the movement. So we can solve that into this place so that we have s sub y will equal to u times s sub x over u cos theta times sine theta minus g over 2 times t squared will become s sub x squared over u cos theta all squared. All right. So with this, I think we are getting somewhere. So, and the other reason why we are using this equation is because it takes into consideration the maximum range. So since we are looking for the trajectory, it means that we are looking for the two-dimensional path undertaken by the projectile. So here we're going to have 6 s sub y will be equal to, here u takes care of u, sine theta over cos theta is going to be tan theta. So recall that sine theta over cos theta is tan theta. So we have s sub x will be equal to s of x into bracket or times tan theta minus g s sub x squared over 2u squared cos squared theta. So from here, we know that s of x is common. S of x is common. We can factor that out. But even before we do that, seeing what we have here, one first thing we can do is this. You know that S sub y is the vertical displacement. Is that okay? The vertical displacement. So, and we know that at the end of the day, that body, when it comes down, S sub y will be 0. When it's, consider this guy, when the body moves downward here and gets to this point, S of y is going to be 0. So we can make this guy 0. So therefore we have 0 is equal to, now we said that S of x is common here. So we can factor out S of x into bracket tan theta minus g S of x over 2u squared cos squared theta. So we have this. So since we have this is equal to 0, the product of this is giving us 0. Definitely, is either S of x is 0 or tan theta minus g S of x over 2u squared cos squared theta is equal to 0. Is either one of this is 0. So if this is 0, then it is going to disappear out of this. So we have this to be equal to 0. So tan theta minus g s of x over 2u squared cos squared theta will be equal to 0. So this one will go there. So that we have tan theta will be equal to g s of x over 2u squared cos squared theta. All right, from here, this guy, so, okay, I actually missed out something. Now, seeing this, you can from here, tell that the equation for the trajectory of the listing is quadratic because if we make from here, if we make tan theta equals, let's say x, or no, let's use another number, let's say m, and we make g over 2u squared cos squared theta, we can make it n. So if we make this one m and make that n, so s of y will be equal to s of x times m. So that will be m s of x minus n s of x squared. So if we arrange this correctly, this becomes ns of x squared minus ns of x minus s sub y, no, plus s of y equal to 0. So you see this quadratic, just like saying ax squared minus bx plus c. So you see this quadratic. All right. So it shows that it is this parabola is the equation depicts the parabola that we have there. All right. So with this we can go on further to derive this equation of range, maximum range from here again, because s of x is what we have here. So if we cross multiply, we have here let's separate this. G s of x is equal to 2u squared cos squared theta tan theta. All right. So what does this give us? This gives us s of x is equal to 2u squared cos squared theta. Remember that tan theta is equal to sine theta over cos theta. So everything all over g. We divide both sides by g. So g leaves there. So cos takes care of one of the cos. And then we have S sub x is equal to 2u squared cos theta sine theta. All right. So what do we have here? We can separate this all over G. We now have S sub x again. Remember that we now have 2 cos theta sine theta again. 2 cos theta sine theta is what? Sine 2 theta. So we now have u squared sine 2 theta over G. And in fact, remember that theta maximum range will be attained if if theta is if the body is launched, the projectile is launched at angle 45 degrees, so that sine 2 theta here will give us sine 90, and sine 90 is 1. So that if theta is equal to 45 gram, we have that S of x is equal to u squared over G. So this is maximum range. All right. So, and that will be it for this video. There are many more things that we could do, because when I was teaching my students these aspects, we derived many other equations. I just can't really remember how we just kept working on. If I especially from here, we did a lot of things, a lot of mixing. In fact, we turned this, we brought in, remember, cos square theta plus sine square theta is equal to 1, so we can replace this by 1 minus sine square theta, and replace this by tan theta, which one? The one that has to do with anything times tan square theta is equal to 1 plus sec square theta. You can work those maths on your own. Just try your hands on, just maneuvering the equation, and they all give rise to different things and different relationships that explains this parabolic curve. All right, this will be it for this video. In the next video, we're going to be talking about waves. So make sure wave is following the series that we started on circular motion. So make sure you do not miss out on that video. God bless you.